So hello everyone, hope you are doing good. So welcome back to my channel. Today we are at day 10th of the April Daily Leetcode Challenge, and we have a easy question in front of us. It's valid parentheses, right? It's question number 20. So what we are given is we are given a string which will have only these characters, right? Which will have only these characters, these six characters, okay? And we have to return if the input string is valid. What is the criteria for validity? See, I will again repeat. Given a string as containing only the string will only contain these six characters, right? And finally, we have to determine if the string is valid. But there is some condition for validity. And let's see what it is. First condition is opening bracket must be closed by the same type of brackets. Okay, open bracket must be closed in the same order. Okay, and every closed bracket has a corresponding open bracket of the same type. So what they mean to say is whenever the opening bracket must be closed, right? It must be closed and in the same order. For example, see in this case, as you can see, this bracket is closed by this bracket, so it's a complete pair. This bracket is closed by this bracket, so it's a complete pair. And this is closed by this, so it's a complete one. Okay, same is in the case of this. But if you see this case, this is open one. It should have been closed with a okay, the circular closing bracket, but it is closed with a square bracket, right? Closing square bracket. So this is not a fair valid string. Okay, so we are returning false in this case. In this case, it is true because everything which is opening is getting closed and in the right order. Okay, and same is the case of this. So I will again repeat. This is the question, and there are six characters, and like let me give you this hint. It's like a stack operation. Okay, whenever you learn stack, you must have seen this kind of example problems, right? So what we have to do is whenever we see this kind of whenever we are seeing a closing bracket, it must have the last element in the stack must be a opening bracket. If it is not the case, return false. Okay. Similarly, when you are seeing this bracket, the last element in the stack must be this. Otherwise, you can return false. Same in the case of this. Whenever you see this thing, the last element in the stack must be this. Otherwise, you can return false. And one more important thing is, see, for example, my input is only one element, which is this. Then see what to do. See, still it's not available, right? They are clearly saying open bracket must be closed, right? So if you're only one element in the string, which is this, then also it will be false because it's not getting closed. So these are some of the edge cases which I told just now. Let us quickly see the code now. I am declaring a stack. I'm naming it a stack as well. It's internal data structure is list. Okay, initially I am increment like add appending the first element of the string. Then I'm starting from the second element of the string till the last element. What I'm doing is if my length of stack is empty, simply append whatever is I, right? And continue. Continue means don't implement the rest of the code. Okay. Don't implement the rest of the code. Whenever the length of the stack is zero, because you will see why it will become zero, we will see now. Just append the character. Okay. See, we are traversing into the second from the second element of the string, that is from index one till the last index. We are traversing. Okay. I is the character in the string, it's not index. Okay. Remember this. My stack already has the first element of the string, right? Which is index zero. So if my length of the stack is zero, simply append the element. Okay, I do not run the rest of the code. If this is now the case which I told you just now, in this edge case, if I see a closing bracket, then the last element in the stack must be opening bracket. If this is not the case, return false. Okay, if it's opening bracket, then pop that out. Okay, see if it is not the case, return false. My program has come to an end. I'm returning false. Okay, but if it's an opening bracket and the last element of the stack is opening bracket, I will pop that out. Okay, this is a push function, and this is a pop function. I'm manually implementing them. Okay, same is the case of this. If the element to be this is the element under consideration right now. Okay, I'm not added into the stack. If I see this is the element under consideration, then the last element in the stack must be this. If it is not the case, I will return false. Okay, if it is fine, if it is the last element of the stack, in that case, I will just append. I will just push that out. Okay. See, this is the operation because of which the stack can become empty. That's why to cover that also, we are doing this. Okay. This is the operation because of which a stack can become empty. Okay. Similarly, whenever the element under consideration is this, the last element must be a opening square bracket. If it is not the case, we should return zero. See, stack of minus one means the last element of the stack. I'm again saying this. See, You must be clear with Python first. If you're not clear, please let me know in the comments. I can go with even more basics then, okay? Because I'm not aware if you are thorough with these things or not. Stack of -1 means is the last element of the stack, right? In Python, if you say -1 -1, that means it will start from the right end, okay, to the left end. So -1 means it's the last element of the stack, right? So the last element of the stack is equal to this square curly bracket. Is not equal to this, then return false. Otherwise, just push it out of the stack, just pop it out, right? Then comes the final else, okay? If none of these things are true, if none of these things are happening, okay, none of these things are happening, what we have to do is just append it, okay? For example, these are the elements in our stack currently, okay? I'm getting another curly opening bracket. I will just append it into the string that, see, are you getting what I'm saying? See, this is the current elements in my stack, right? All are opening ones, okay? All are opening ones. There's no closing until now. That means I can again append it, okay? And the above cases won't be running in that case, okay? Only if there is a closing one coming, these cases will run, right? But we are having opening one. So what we'll do is we'll simply append it, okay? We will append it and we'll leave it, okay? And finally, I'm returning if my length of stack is equal to see, because they've clearly seen, they've mentioned opening bracket must be closed. Okay, so only if my length of the stack is 0, then only then I can confirm that all the opening ones had a closing one. And in the see these conditions you are seeing, right, this will be true only only if my length of stack is 0. Finally, after doing all this, okay. Otherwise, I cannot confirm if all of them were closed in the same order or by the same type of bracket. And every bracket must be having a closing one, right? Every opening thing must be having a closing corresponding bracket. So to ensure all these things, finally we have to see if the length of the stack is equal to 0 or not. If it's not the case, then it won't be, we can't confirm it to be true, right? So that was all, friends, for today. It's a linear solution. Its time complexity is over n. Space complexity, we are using a stack which will be again of the order of n. Okay. So yeah, friends, that was all for today. If you have any doubts, like, see, if you are not understanding one of these things, please do comment below. I will help you explain them. Okay. So yeah, friends, that was all for today. Thank you.